Welcome to our channel. Today we're diving into the strangest laws of physics that boggle the mind and challenge our understanding of the universe. You know, the kind of stuff that makes you question everything you thought you knew about reality. We're talking about concepts so bizarre, so counterintuitive, they wouldn't even make it past the scriptwriters of a sci-fi movie. But here's the thing about the universe, it doesn't care about our feeble human intuition. It just is. And sometimes just is involves particles being in multiple states at once, information traveling faster than light, and cats being both alive and dead. So, buckle up, get ready to expand your minds and maybe even have your realities slightly fractured. Because things are about to get weird. Alright, let's talk about quantum entanglement. This phenomenon is one of the most intriguing and perplexing aspects of quantum mechanics. It challenges our understanding of the universe and defies the classical notions of space and time. This is the one Einstein famously called spooky action at a distance, and for good reason. He was deeply troubled by the implications of entanglement, as it seemed to contradict the theory of relativity, which states that nothing can travel faster than the speed of light. Imagine two particles, linked in a way that even when separated by vast distances, light years even, they still influence each other instantaneously. This connection is so profound that the state of one particle directly affects the state of the other, no matter how far apart they are. Think about that for a second. Instantaneously, faster than the speed of light. This instantaneous connection defies our everyday experiences and the laws of classical physics. It's as if you have two coins, flip them at the same time, and one always lands on heads while the other always lands on tails, no matter how far apart they are. This perfect correlation is what makes quantum entanglement so mysterious and fascinating. Spooky, right? The idea that two particles can be so deeply connected that they transcend the limitations of space and time is truly mind-boggling. But it's not just some theoretical mumbo-jumbo. Quantum entanglement has been experimentally confirmed, and it has the potential to revolutionize fields like computing and communication. Scientists have conducted numerous experiments that demonstrate the reality of entanglement, using sophisticated equipment and techniques. Imagine a world with unhackable networks or computers exponentially more powerful than anything we have today. Quantum entanglement could lead to the development of quantum computers that perform complex calculations at unprecedented speeds, and quantum communication systems that are virtually immune to eavesdropping. That's the power of quantum entanglement. It opens up possibilities that were once the realm of science fiction, bringing us closer to a future where technology is limited only by our imagination. It's a glimpse into the fundamental interconnectedness of the universe at the most fundamental level. This interconnectedness suggests that the universe is far more complex and intertwined than we can currently comprehend. And it all starts with these tiny entangled particles. These minuscule entities hold the key to unlocking the mysteries of the universe and could pave the way for groundbreaking advancements in science and technology. Next up, we have Heisenberg's uncertainty principle, and this one is a real head-scratcher. In the realm of quantum mechanics, it turns out that the more precisely you measure one property of a particle, like its position, the less you can know about another property, like its momentum. It's not a matter of our instruments not being good enough, it's a fundamental limit imposed by nature. Imagine trying to pinpoint the exact location and speed of a buzzing fly. The very act of observing it, of shining a light on it, changes its trajectory. Heisenberg's uncertainty principle tells us that at the subatomic level, reality is not a set of fixed values, but rather a blurry haze of probabilities. It's like the universe is playing a cosmic game of hide-and-seek with us, always keeping some secrets hidden. Now let's talk about everyone's favorite feline thought experiment, Schrödinger's cat. This one is a doozy. Imagine a cat sealed inside a box with a device that has a 50% chance of releasing a lethal poison. Until we open the box, we have no way of knowing if the cat is alive or dead. According to quantum mechanics, the cat exists in a superposition, a state of being both alive and dead simultaneously. It's only when we make an observation, when we open the box, that the wave function collapses, and the cat's fate is sealed. Schrödinger's cat is not about animal cruelty. It's a powerful illustration of the strangeness of quantum superposition and the role of observation in shaping reality. It's a reminder that at the quantum level things aren't always as they seem. The double-slit experiment is a classic demonstration of the wave-particle duality of matter. This experiment, first conducted by Thomas Young in 1801, has puzzled and fascinated scientists for over 2 centuries. It elegantly showcases the mysterious nature of light and particles, challenging our understanding of reality itself. It's been called the most beautiful experiment in physics, and for good reason. The simplicity of its setup belies the depth of its implications. By merely shining light through 2 narrow slits and observing the resulting pattern, we uncover the dual nature of light, behaving both as particles and waves. It's deceptively simple, yet its implications are profound. The experiment forces us to reconsider the very nature of reality and the role of the observer in the quantum world. It suggests that particles can exist in multiple states simultaneously, a concept that defies our everyday experiences. Imagine shining a beam of light through 2 slits. At first glance it seems like a straightforward task. You'd expect the light to pass through the slits and form 2 distinct bands on the screen behind. You'd expect to see 2 bright bands on the screen behind, right? This is what classical physics would predict, based on our understanding of how particles and waves behave. But that's not what happens. Instead of 2 bright bands, we observe something entirely different, something that defies our classical intuition. Instead, we see an interference pattern, a series of light and dark bands, as if the light waves are interfering with each other. This pattern is characteristic of wave behavior, suggesting that light is not just a particle, but also a wave. The real mind-bender is that this happens even when we fire single photons, one at a time. Each photon seems to interfere with itself, creating the same interference pattern as if it were a wave passing through both slits simultaneously. It's as if each photon is somehow going through both slits simultaneously, interfering with itself. This phenomenon challenges our classical understanding of particles and waves, suggesting a deeper, more complex nature of reality. It's like throwing a tennis ball at a wall with 2 openings and seeing it pass through both at the same time. This analogy helps us grasp the strangeness of the quantum world, where particles can exist in multiple states and locations simultaneously. The double-slit experiment shows us that the act of observation, of measurement, can fundamentally alter the nature of reality. When we try to observe which slit the photon passes through, the interference pattern disappears and we see 2 distinct bands, as if the photon decided to behave like a particle. It's a powerful reminder that the universe is far stranger than we could have ever imagined. The double-slit experiment not only reveals the dual nature of light and particles, but also hints at the profound connection between the observer and the observed, suggesting that our very act of observation can shape the reality we experience. Finally, we come to the great unknowns, dark matter and dark energy. These 2 components are some of the most perplexing and fascinating aspects of our universe. Despite making up about 95% of the total mass energy content of the cosmos, they remain shrouded in mystery. These enigmatic entities make up the vast majority of the universe, yet we know surprisingly little about them. Dark matter and dark energy are not just abstract concepts, they are fundamental to the structure and fate of the universe. We can't see them directly and we don't know what they're made of. Scientists have been trying to detect dark matter particles using highly sensitive instruments, but so far, it has eluded direct detection. We know dark matter exists because of its gravitational effects on visible matter. For instance, the way galaxies rotate and the way light bends around massive objects, known as gravitational lensing, provide indirect evidence of dark matter's presence. It's like an invisible web holding galaxies together. Without dark matter, galaxies would not have enough gravitational pull to hold themselves together, and they would fly apart. And dark energy? Well, that's the force responsible for the accelerating expansion of the universe. This mysterious energy is pushing galaxies apart at an ever-increasing rate, counteracting the pull of gravity. Think about that for a second. The universe isn't just expanding, it's expanding at an increasing rate. This discovery has profound implications for the ultimate fate of the universe. The universe isn't just expanding, it's expanding at an increasing rate. Imagine throwing a ball in the air, and instead of it slowing down and falling back to the ground, it keeps accelerating upwards. It's like throwing a ball in the air, and instead of falling back down, it keeps going faster and faster. This analogy helps us grasp the counterintuitive nature of dark energy's effect on the cosmos. Dark matter and dark energy are reminders that we've only just begun to scratch the surface of understanding the universe. They challenge our current theories and push the boundaries of our knowledge, They're the next great frontiers of physics, and unraveling their secrets will undoubtedly lead to even more mind-bending discoveries. As we continue to explore these cosmic mysteries, we may find answers to questions we haven't even thought to ask yet. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating insights into the world of physics. See you next time. Remember, the universe is full of mysteries, and it's our job to explore them. Keep questioning, keep learning, and never stop being amazed by the wonders of the cosmos. Until next time, keep looking up.